Hello, everybody. So today we're going to begin our discussion in Chapter 8, Section 1. And Chapter 8, Section 1 is kind of new information that you probably have not really covered in pre-algebra before. So it's going to begin introducing uh, some terminology and some notation that you will see a good bit of in geometry and Algebra 2. And that is the main word here is what a polynomial is. And if you recall in the last section or the last chapter that we studied, we talked about what a monomial was. And a monomial was a single term. And we had you practice identifying whether something was a monomial or whether it was not. So as an example, a monomial would be like 2x squared. Another monomial would be 11, or you could have x squared over 5. That's a monomial. Examples of things that are not monomials, x plus y. So these are not monomials. X divided by y, that would not be a monomial. So what we're going to now do is expand that a little bit and show you that there are other things that you can have that are longer, have more terms in them, and they can be classified as a binomial or a trinomial. But the kind of overarching name for all of those is called a polynomial, which basically is saying it's many individual terms put together, in this case, using a sum or a difference. So let's take a look at what a monomial would be. An example of a monomial right here you can see is 5x. And we also showed you some other examples, or I just showed you some other examples. 2x squared would be a monomial. Another monomial would be just the number 11. It's a single term by itself. Or we could also have x squared over 5. That is also a monomial. Now, when we get into what is called a binomial, as in like a bicycle has two wheels. You're going to have two separate terms. There's, in this case, a 2x squared and then a plus 7. Notice the terms are separated by a plus, and that's kind of your indicator as to how many terms you have is going to be how many pluses or minuses that you have. So since we have one plus, it creates two different terms, 2x squared and then a 7. And so that would be called a binomial. Another example of a binomial would be, I don't know, y plus 11. So since there's a plus, it separates those two things, and there are two terms. We could have z divided by 4 minus 6. That would also be a binomial. So anything with two separate terms that are being separated by either an addition or a subtraction sign. So the next one that we would have would be called a trinomial. So I think you're probably beginning to see the pattern here. When we have mono means one, binomial is going to mean two, tri is going to mean three. And as you can see there are two different signs. It actually doesn't matter if they're both plus or both minus, or one's a minus and one's a plus. It really doesn't matter. What's important is those two signs separate it into three different terms. So we have an x cubed, then we have an x, and then we have a constant. And when you have that, when you have three separate terms like that separated by two different pluses or minuses, that is called a trinomial, and because it has three terms. So there's many variations you can have of that. You could have x plus y plus z. That's a trinomial. You could have x squared plus 3x minus 1. That is also a trinomial. Anything that's going to have three terms and it's three separate monomials as one is going to be called a trinomial. Now, something to keep in mind is the word polynomial right here. Whoops, I thought I had my highlighter on. This polynomial right here is a blanket heading for all these monomials, binomial, trinomial, any number of terms in an algebraic expression can be called a polynomial. And so really much past three terms, we just call them all polynomials. So if it has 4 or 5 terms, we just call it a polynomial. Now, a degree of the monomial is the sum of the exponents of all of its variables. So very important here. So the degree is going to be, how you find the degree is that you add up all of the exponents on the variables. So as an example, if you just had x to the fourth, we would say the degree of that is equal to 4. But it's simple because that's the only number we have. Now, if we had an expression like x to the fourth, y to the seventh, you can see that is one single term because it is not separated by a plus or a minus. So the degree of that term would actually be the sum of both of the powers. In this case, 4 plus 7 would be 11. So the degree of that term would be 11. Now, when these monomials, or I shouldn't say these monomials, but when these terms have various degrees, we call them by different names. So if a term has a 0 degree, it is called a constant. An example of a constant would be the number 12, right? There's no variable, there's nothing taken to a power, so that's just a constant. Now, a linear term would be when you have x to the first power. So an example of that might be 3x, just like that. There's a linear term because the power on the x, remember we talked about, if there's nothing written there, it is actually a 1. Now a quadratic would be of a degree 2. So an example of that might be, I don't know, 2x to the second. I don't want to use that actually. Let me back up. I'm going to do 4x to the second. And I didn't want to use a 2 in the front because I didn't want you to get mixed up. The quadratic is referring to the x being taken to the second power. Cubic is going to be the third power. So if you have anything with x to the third power, that is going to be a cubic term. So like, I don't know, 7x to the third power. That would be called a cubic term. Now, again, much past 3, we usually just call them polynomials or higher order polynomials. But I'm going to go ahead and show you 4 and 5. 4 is called a quartic, and 5 is called a quintic. And then after 6 or more, we usually say 6th or 7th degree and so on. But to be honest with you, we usually start that 6th degree and 7th degree with the 4. So usually we say 4th degree, 5th degree, 6th degree, 7th degree. So you can use either one, quartic, quintic, or you can say 4th degree, and that's perfectly fine. But an example of those would be maybe like 1/2 x to the 4th. That's a 4th degree, also known as a quartic. And then a 5th degree might be 6x to the 5th power. And that would be a quintic, or you could just say 5th degree. So the way that you classify these polynomials is they get 2 classifications. They get a classification based on how many terms they have, and they get a classification based on what the highest degree is. So as an example now, if I had that, 2x to the third plus 4x minus 1, we would call that a cubic. It's called a cubic because the highest power is 3. And it would be called a trinomial because it has 3 individual terms, the 2x cubed, then the 4x, then the minus 1. So the classification would be a cubic trinomial. All right. And it says vocabulary. Standard form of a polynomial are terms written in order from greatest to least. So another kind of just procedural thing that you'll see a lot as we begin to work with these algebraic expressions is that whenever they are written, when they are written in the correct order, we always want to write them so we have the highest power first, and then they subsequently get lower. So you can see we started with an x to the third, then it becomes x to the second, and then it becomes x to the first, and then finally there's no x here at all. It's gone, and we just have the number 7. So when you order a polynomial from the highest power down to the lowest power, that is called standard form. That's this right here, standard form of a polynomial. Now, another vocabulary that we need to talk about is what the leading coefficient is. Now, the leading coefficient, when something is in standard form, which is really important, when it's highest power to lowest power, the leading coefficient is going to be this very first number on the lead term. So that's why it's called leading coefficient. But it's really important to remember that that leading coefficient is only found whenever it's in the highest to lowest power. So from 3 to 2 to 1. All right, so this is what we're going to do. We are going to take these example problems, there's 4 of them, and we're going to put them into standard form, and then we're going to state the leading coefficient. So the first thing to do is to recognize what powers do we have here. We have second power, fifth power, and since there's nothing there, we know it's going to be the first power. So we do need to order those from greatest to least. So the greatest power here is 4x to the fifth, and then we would have 3x squared, and lastly, we would have negative 7x. And you could say x to the first if you really wanted to, but it's not necessary. So you can see we have the powers. They go from the highest power to the lowest. Now we are in standard form. The leading coefficient is going to be that first number out in front of the variable. So in this case, the leading coefficient, I'm going to write LC for leading coefficient, is equal to 4. Now, if I wanted to classify this, and it doesn't ask us to do that in the directions, but I'm going to go ahead and do that anyways. You classify this with 2 names. The first name is how big of a power do we have? And that's the fifth power. So if you look up here, when we have the fifth power, that is called a quintic. Quintic. And the second thing that we classify this with is how many terms we have. In this case, we have 1, 2, 3 terms. So when you have a fifth power, it is called a quintic. And 3 terms is called a trinomial. So that would be called a quintic trinomial. Now we're going to try the next one. In this one, you can see there's 4 terms in this one. And we're going to order from the highest power to the lowest. So the highest power we have is to the fourth. So it's going to be negative 2y to the fourth. Then we're going to have negative 6y to the third. Then we're going to have a positive 5y. And then lastly, we're going to have a minus 9, like that. So you can see the powers are going from the highest to the lowest. The next thing we need to do is to identify what the leading coefficient is, which is the first number. So it's negative 2. And then I'm going to go ahead and classify this by its highest power and how many terms it has. The highest power is 4, so that is called a quartic. And it has 4 terms. Now, if we go up here to see how many terms, once you're beyond 3, so a monomial is 1, a binomial is 2, a trinomial is 3. Once we go beyond a trinomial, when there's more than 3 terms, we can just call them a polynomial for many terms. So we're going to call this, oops, went a little too far. That is called a quartic polynomial. Now, number 3 is done in a similar fashion. We are going to order them from greatest to least. So 4x to the fourth minus 2x squared, then minus 3x, and then plus 8, just like that. So highest power to lowest, we need to identify the leading coefficient. Leading coefficient is equal to 4. Now, what is that? That is also a quartic. It's a quartic because the highest power is 4. And because it has 4 or more terms, we're going to also call that a polynomial. Now, the last one I'm going to show you today has more than 4. It actually has 5 terms. So we need to go by the highest power first, which is negative 7y to the 6th. Then we have minus 5y to the 3rd. And it's not a bad idea to cross these out as you're using them so you don't forget to write one. Then we have minus 2y squared. Then we have plus y. And then plus 10. Just like that. So we have the highest power, 6, and then 3, then 2, then 1, and then there is no power, which is 0. So there it is in standard form. The leading coefficient is negative 7. And we would call that a quintic polynomial. Nope, I lied about that. That is not a quintic. Quintic would mean it's 5. The highest power is a 6th power. I apologize. So this is kind of easy to mix up. The highest power is a 6th power, and so beyond 5th power, we just call it a 6th degree polynomial. So that's what I wanted to show you today. I appreciate you listening. And as always, if you have any questions, feel free to email me. Have a great day.